To cache or not to cache, a question pondered by great philosophers for centuries. And today you are getting my version of it. Let's get into it. Now, caching. It sounds simple, right? And that's when you should know that it's not simple. So in software engineering, if anything sounds simple, it's probably not, right? And especially caching. So how do you cache things, right? You check database, you check cache. If something is missing in the cache, you hit the database and cache it. Sounds simple, right? But what happens when you want to invalidate cache, right? You run into one of the two hardest problems in software engineering: naming variables and cache invalidation. So it may sound like a joke, but trust me, it is one of the biggest headaches in a distributed system. Like right when I was working in my first job, there were so many caching layers and no one had access to clear them. Or rather the at least the CDN layer, right? No one had access to clear the CDN layer, and I had to go live with some changes, and it was my literally my last working day, right? But the changes were not visible, and the next day when the cache was automatically invalidated, the CDN cache, the changes were present, but no one was willing to accept or listen that it was the cache issue. But why do we need so many cache layers, right? So there are very good reasons, but there are also some bad reasons. So today I want to focus on the bad reasons, right? A good reason could be like, your query patterns, that something won't change, and there are various ways to handle it, right? And it's a separate topic, but when it comes to bad reason, it's quite simple. Your database schema is inefficient and your queries are inefficient, right? So those are the two main reasons where people just add caching and call it a day, right? So what happens? There is a query which you wrote in a hurry, right? And you wanted to go live with something, and like you have a deadline, you need to deliver it by today 12 a.m. If you deliver it at 12 a.m. 1 minute, then you will be fired. Okay, so you have to do it. What do? You ask Claude, Cursor, Codex, or ChatGPT to give you some code that works, right? And it works. You deploy it to production and it works for a while. But once the data increases, maybe it's a new table or maybe it's usage spikes, your application starts to stop working, right? Maybe your database is utilizing 80, 90, 100% of the CPU. And what do you do in those scenarios? Again, you need to fix it by 7 p.m. today, or else. So what do? You add a caching because that's the easiest solution. But easiest solution is not always the right solution, but we do it anyways. So what are the solutions, right? First of all, there is no actual deadline where you can't be a minute late. So keeping that in mind, try to optimize the queries, right? It's okay to write inefficient queries initially. It's okay to not understand everything when you are on a deadline, but it's not okay to leave it that way, right? Try to revisit them and try to optimize them by understanding those queries, especially if you are working with ORMs, right? So I work a lot with JPA and it's amazing. It saves a lot of time and it helps me write code which is easy to read, and I don't have to write a lot of SQL queries because of it. But it's a double-edged sword, right? Because there are a lot of n plus 1 queries. So for anyone who is not familiar with n plus 1 concept, right? Basically, whenever you need to fetch one entity is just a table in Spring Boot, right? So if you want to fetch something and it has a list of other entities, right? So for example, you have a superhero team, right? A superhero team table, and there could be multiple superhero teams and each team can have multiple members. So let's assume we have Avengers, right? and each team will have multiple members. There's Iron Man, there's Black Widow, there's Hulk, there's Thor. And now each time you want to do some processing, right? You have, or you already have the superheroes entity in your memory loaded, and you want to fetch all the superheroes, and you just loop over it, because in Java you get a list of like one to many relationship, so list of heroes for within that entity, within the superhero team entity. And now what happens is, it seems like you are just looping over a class list, but what you're doing is, especially if you have lazy fetching, right, where you don't directly fetch all the related data in one DB query, and ideally it should always be lazy fetching, but there are obviously cons to it. So what happens is, you are making n queries. N is the number of superheroes in this instance. So you don't necessarily need to make n queries, right? Maybe there are scenarios where there is a limit, n is limited. Maybe you need to fetch, even batching is fine, right? Maybe you can fetch 10 heroes at a time, but there should be some scenario where you are not making n queries, right? If you have 100 heroes, right, you will fire a database query for each one of those, right? And it starts to add up, and it becomes very expensive. And the worst part is, it's very easy to miss. It does not matter if you're using Spring Boot and JPA. It does not matter if you're using Node with some other ORM. It does not matter if you are using Golang. If you are using an ORM, you are paying that price. So be very mindful, right? Very mindful of what kind of queries you are running, and always try to validate and verify the queries. At the end of the day, like, we are humans, we tend to make mistakes, but what is the worst part is, don't rely on AI, right? This is the kind of mistakes which AI will make shamelessly, and when you question it, it will say, yeah, you are right, I will fix it for you. But it won't fix it by them. The AI won't fix it by itself, right? You need to instruct it, and to instruct it, you need to understand that there is an issue. Okay. And a lot of times, a simple data projection also helps, right? So what do I mean by data projection? You have a table with maybe 50 columns, but you do not need all the 50 columns for one API. So a simplest example would be a paginated list, right? It does not matter if it's a cursor based pagination or it's a offset based pagination. It's a pagination based API. So in those APIs, you are generally not showing all the columns of a table, maybe 4, 6, 10 columns for the most cases, right? And but in the backend, maybe you are fetching all the data, and it could be very inefficient. So just use, or rather fetch the data that you need. It is also one more method which will optimize your backend like a lot. And now, now coming to the last point, right? Why am I against caching? Because as I gave you the example when we started this video, caching causes a lot of issues. It seems harmless, it seems helpful, but it's only helpful if it's done right, right? And cache invalidation really is complex. Okay. And you can't always rely on caching. You should first explore your options, and caching is also expensive, right? We are storing data in memory, and memory is expensive. If it was cheap, maybe we would do all our operations from cache or from in memory. We would find some abstraction layer. There is a reason we don't do it. It's expensive. So as your application grows, you will introduce more complexity. So try to keep it simple. Try to use cache only when required. So that was my version of why you should not always cache things. I just wanted to add my opinion and bit more nuance to caching, like the why behind the caching, how and when are separate topics. Maybe I will make videos on those topics in the future. Let me know if you have any specific topic which you want me to discuss about. But for now, I think I have said what I wanted to. So thank you for watching the video, and I'll see you guys in the next one. Thanks.